Yes. So can you solve this problem in geometry, Josh? This was taken from here. Let's show. You can pause this video for a moment if you want to try before checking out the solution of Joshua. David Wong is one of the, I think, while you're solving, is legendary among the math those involved in the mathematical Olympiads. He is the one who has contributed the most number of problems for the IMO, International Mathematical Olympiad. So explain what
Yes.
no, verbally.
Okay. After.
Ayun.
After. That will be more easy to understand. Uh, since B and C is supplementary to A and C, then since A and C is equal to ALB, B and C is also supplementary to ALB. So therefore, these two are supplementary. So that means B and GL is cyclic. Here's LN. Since N and L are midpoints, these two segments are parallel. Yes. Then since B and GL is cyclic, ABM is congruent to NLA. No orange. There's no orange, RIP. Let's erase this. No. And it's repaired. Okay. So then LN is since LN is parallel to AC, then NLA is congruent to LAC.
Put your parallel ano. Parallel. So cyclic because if you draw ano, are you able to draw
Why?
a circle? Para so they will know that it's really
Demonstration. Wait.
yes, demonstration of the
Uh,
congruence of
the
those two,
cyclicity.
those two angles.
Pretty sure.
A little bit. Okay pa. Yes. So
Somewhere there because the figure is not really very
yes,
accurate.
accurate. So
There's no way to
it
make
means
those two angles equal.
angle ABM is congruent to angle ALN, no?
We do a little bit of cheating here.
Yes. Because they
There, okay, somehow. So slightly imperfect, but of course you can see. These are both intercepting the same arc, which is
intercepting.
arc NG. So obviously they must be the same measure. Okay, then because of this, where's NLA here? NLA is congruent to ABM and it is equal to congruent to LEC. So by transitivity, of course, ABM is congruent to LEC. UED. So the other way around is the if and only if, of course, when we remove this, and then we remove, oh wait, this can be kept, can they? Oh yes, anyway. So, except this red one, let's imagine it doesn't exist. Then I'll just put it here. So, of course, verbally, LAC is is congruent to NLA here. We just go back. It's basically that simple. So, we cover this NLA. LA, wait, let's remove it for now. LAC is congruent to ABM. Going back, NLA is congruent to LAC because LN is the midline, a mid segment, and LN is parallel to AC. Then because of that, NLA was parallel to is congruent to LAC. So of course we get this angle back here again. So again, because of this means that because of the cyclic quadrilaterals properties, if there are two angles such as NBM and NLA that are congruent, NLG actually is more appropriate. Anyway, NLG and NBG are congruent, of course, then BNGL is cyclic again. So because it is cyclic, then B and CG is supplementary to BLG. So therefore, since these are supplementary, A and C, which is supplementary to the red angle, is also congruent to BLG or BLA. This is basically the opposite way around. I can wait, I will edit this. Uh, this is also to demonstrate that it is literally the opposite of this proof. I will not write anything anymore, so you can really see that this is indeed the opposite of this proof. Wait. Well, I realize it's not really exactly backwards, but it's more of well, it's still backwards basically. There's a change of words. Oops.
Great technology.
And this is also a demonstration that it's literally the opposite way around. There is nothing completely different about the proofs. Because eventually it all boils down to because cyclic quadrilaterals really have that intrinsic property of if and only if and only if these two are supplementary, and then also these two are congruent. Literally the only text that I had to write. And actually only the therefore. To further the cheating, I will do this QED is even there. So it reads well and it also makes sense. This is almost completely made out of this one.
Yes.
So
Nice.
nice. So this also this is also it's a hard to think of solution. So thanks for watching.
Thanks for watching.
Bye.